Hello and welcome to our lecture, Unlocking Sustainability Through Energy Efficiency, Strategies, Policies, and Implementation. In today's world, sustainability is at the forefront of global discussions, and achieving it heavily relies on our ability to enhance energy efficiency. Let's get started and explore how this vital pillar supports sustainable development across the globe. My name is Muhammad Tash. I'm a sustainability expert with more than 23 years in sustainability sector in the energy industry. In today's lecture, we will start by discussing the basic principles of energy efficiency. It's about doing more with less, reducing the amount of energy required to provide products and services, and understanding its pivotal role in global sustainability efforts. Next, we will explore how energy efficiency aligns with broader sustainability goals. This includes its impacts on reducing greenhouse emissions and conserving our precious natural resources. We will then identify actionable strategies and the cutting-edge technologies that both organizations and individuals can employ to enhance energy efficiency. We will also examine the supporting frameworks, how policies and regulations can either promote or hinder the advancements of energy efficiency. Finally, we will discuss practical steps for implementing energy efficiency measures that lead to successful, sustainable outcomes. Before we continue, let's take a moment to review some key statistics relevant to our discussion. Starting by a quick overview of global energy consumption by source, examining the trends from 1800s to 2022. Let's begin with a snapshot of 2022. Notice the diversity in energy sources from traditional biomass, contributing to more than 11,000 terawatt hour, to oil, leading at more than 52,000 terawatt hours. Notably, renewable energy sources like wind and solar are making significant inroads, together generating nearly 9,000 terawatt hour. Now, looking at our historical graph, the x-axis spans from the year 1800s to 2022, while the y-axis measures energy consumption in terawatt hours. Each color represents a different energy source, tracing its usage through time. You can observe the historical dominance of coal and oil. However, the recent decades show a remarkable shift. Renewables, including wind and solar, have surged, reflecting a global push towards sustainable energy practices. This graph not only shows the growth in total energy consumption, but also highlights the pivotal shifts towards more sustainable and diverse energy portfolios. Understanding these trends is crucial as we navigate the challenges of energy sustainability and climate change. It shows us where we have been and where we need to focus our efforts to ensure a sustainable future. As we go through into the recent findings of global energy consumption by the International Energy Agency, IEA, we will explore the dynamics of global energy demand and its implications for sustainability. According to IEA, global energy demand has surged, growing by 2.3% in recent years. This marks the fastest increase in the last decade. Such a rapid rise in energy consumption presents both challenges and opportunities in our mission for sustainable energy practices. Despite notable improvements in energy efficiency, the stark reality is that this acceleration in energy usage significantly contributes to global emissions. It underscores the ongoing challenge. While we are becoming more efficient in using energy, the total volume of energy consumed continues to drive up our carbon footprint. This situation brings to the forefront the critical role of energy efficiency. Enhancing our energy efficiency is not just about technological improvements, it's also about broader adoption and more profound behavioral changes across societies. In conclusion, as we continue to witness a growing global energy demand, the need for rigorous energy efficiency measures becomes more apparent. These measures are pivotal in our collective efforts to curb emissions and foster a sustainable future. Moreover, based on insights from IEA, the global economy could double in size by the year 2040. This is not just a possibility, it's within our reach with the right energy efficiency policies. This scenario underscores the tremendous potential of energy efficiency measures. These strategies are pivotal, not just for reducing energy consumption, but for enabling sustainable economic growth. By decoupling economic expansion from energy demand, we pave the way for a sustainable future. Effective energy efficiency policies are the prerequisite in this process. They facilitate a balance where economics can thrive while managing their energy use more wisely, thus protecting our environment and conserving resources for current and, of course, future generations. Turning on the vital role of energy efficiency on combating climate change, today energy efficiency is not just a resource saver, but a crucial defense against global warming. According to the United Nations Environment Programme, implementing energy efficiency measures could reduce greenhouse gas emissions by up to 40% by the year 2030. This statistic underscores the power of energy efficiency in our global fight against climate change. Energy efficiency stands out as one of the most effective tools available. By optimizing how we use energy in industries, buildings, and transportation, we can significantly decrease our environmental footprint. So, by reducing energy demand through efficiency, it means less burning of fossil fuel, fewer emissions, and ultimately a healthier planet. It's a direct and impactful way to address the urgent challenge posed by climate change. In the previous section, we explored a range of statistics highlighting the impact of energy efficiency on sustainability. Now, let's check some fundamental definitions associated with energy efficiency. Starting with the energy efficiency itself. What is the meaning of energy efficiency? Energy efficiency, often abbreviated as EE, revolves around optimizing our energy usage. The aim is to perform the same tasks, whether it's heating our homes, running our factories, or powering our devices, using less energy. So, why focus on energy efficiency? The answer is straightforward. By using energy more efficiently, we reduce our overall energy consumption, save costs, and most significantly, lessen our environmental impacts. It's about doing more with less. Again, It's about doing more with less without compromising on quality or productivity. And this is a significant point. How can you achieve energy efficiency without compromising on quality or productivity? This approach is not just beneficial, it's essential. As we strive towards a sustainable future, energy efficiency acts as a foundational pillar that supports a wide range of sustainability goals, from reducing greenhouse gas emissions to conserving natural resources. Now, let's move into a crucial metric in the context of energy management: specific energy consumption, or SEC. This measure is pivotal, engaging the energy efficiency of production processes. Specific energy consumption quantifies the amount of energy required to produce a unit of output. It's typically expressed in terms such as kilowatt hours per ton of product manufactured. Understanding specific energy consumption helps industries monitor and optimize their energy use. And the question may arise here: why focus on specific energy consumption? Lower specific energy consumption values or means signify, or it tells that uh, with lower specific energy consumption, it means less energy is used to produce the same amount of product, indicating a more efficient process. So, by improving SEC, it's not just about cost saving, it's about sustainability. Since by reducing the energy per unit of production, industries can significantly decrease their environmental impact, contributing to a more sustainable future. Next, let's discuss deeper the significance of energy efficiency. The first point for significance of energy efficiency is reducing our environmental impact. Efficient use of energy is paramount. It enables us to lower overall energy consumption, which is fundamental in every strategy aiming to achieve sustainability. By optimizing how we use energy, we can perform our daily tasks and power our industries without excessive consumption. What does this reduction in energy consumption mean for our environment? It leads to significantly lower emissions of greenhouse gases and pollutants. This is crucial as these emissions are the main drivers behind global warming and air pollution. By implementing energy efficiency measures, we can mitigate these environmental impacts effectively. It's not just about saving energy, it's about sparing our planet from the adverse effects of climate change and ensuring cleaner air for present and future generations. The second significant issue of energy efficiency is about the intersection of energy efficiency and economic efficiency. And the question here: how strategic energy management contributes to substantial cost saving across multiple sectors. Energy efficiency is a critical lever in reducing the operational energy requirements for production, as well as for heating, cooling, and lighting. Through the adoption of advanced technologies and optimized processes, different sectors can achieve significant reduction in energy consumption. This reduction in energy demand directly translates into lower energy expenses. For consumers, for example, it means less money spent on utility bills. For businesses, it results in decreased overhead costs associated with energy. Moreover, for governments, it alleviates the fiscal pressure involved in energy production and the maintenance of aging infrastructure. Let's consider the broader economic landscape. By minimizing the energy intensity of our industries and public services, we not only enhance the sustainability of these systems, but also foster an environment conducive to economic growth and stability. Reduced energy costs free up resources, potentially redirecting investments towards innovation and expansion. As we move forward, it's imperative that we continue to integrate energy efficiency strategies into our economic planning and development policies. Doing so will ensure a resilient and sustainable economic future. Next, we will examine the significant role of energy efficiency in supporting sustainable economic growth. Energy efficiency enables industries and services to achieve higher outputs or provide more services while maintaining or even reducing energy consumption. The principle is fundamental in reducing operational costs and enhancing overall productivity in a sustainable manner. A crucial aspect of energy efficiency is its ability to decouple economic growth from excessive natural resource consumption. By optimizing energy use, we can sustain economic expansion without increasing our resource footprint. This is essential for reducing our environmental impact and to promoting a balanced ecological future. The strategic application of energy efficiency measures supports not only economic stability but also ensures that growth is environmentally sustainable. This approach helps preserve natural resources for present and future generations while still meeting the current economic demands. Energy efficiency also has a vital role in mitigating environmental degradation. Through reducing the overall need for energy production, this reduction is crucial because traditional energy production processes such as the extraction, transportation, and the processing of fuels are associated with significant environmental challenges. These processes are often linked to severe ecological disruption, including deforestation, habitat destruction, and soil erosion. Each of these activities not only depletes our natural resources, but also destabilizes ecosystems, leading to long-term ecological damage. By enhancing energy efficiency, we can decrease these harmful impacts. Improved efficiency means less fuel needed, fewer extraction, and less transportation and processing. This directly contributes to decreased environmental degradation and promotes a more sustainable interaction with our planet's natural resources. Okay, now we will talk on energy efficiency and air quality improvement. This is there is a critical relationship between energy efficiency and air quality. Our objective here is to understand how engineered solutions in energy systems reduce harmful emissions. Enhanced energy efficiency in power generation, for example, and industrial processes, significantly reduces emissions of sulfur dioxide, nitrogen oxides, SOx and NOx, and particulate matter, PM, whether it's PM10 or PM2.5. These substances are mainly produced from the combustion of fossil fuels and have a substantial impact on air quality. The principle is straightforward. Improving energy efficiency means less fuel is needed for the same output. This leads to a direct decrease in the volume of emissions. through incorporating advanced combustion technologies and optimizing energy use, we can achieve uh, significant reductions in these pollutants. The environmental and health benefits of reducing these emissions are profound. Lower levels of SO2 and NOx, which contribute to smog and acid rain, along with reduced particulate matter, improve air quality and visibility. This not only benefits our environment, but significantly enhances our public health, reducing respiratory and cardiovascular conditions associated with poor air quality. I invite you to look into our World in Data website and check the deaths resulted annually from air pollution. So it's imperative that we continue to push for improvement in energy efficiency as a key strategy to combat air pollution. Each step forward not only supports sustainable development, but also protects human health and the environment. Now, let's explore the significant connection between energy efficiency and the Sustainable Development Goals SDGs. Energy efficiency is instrumental in achieving Sustainable Development Goal 7, which aims to ensure access to affordable, reliable, sustainable, and modern energy for all. As we have seen, energy efficiency involves using less energy to perform the same task. Scientifically, it's quantified by the ratio of useful output to energy output, with higher values indicating greater efficiency. From an engineering perspective, energy efficiency is achieved through advanced technologies and designs that optimize energy use in appliances, buildings, and industrial processes. These innovations are crucial for reducing our carbon footprint and enhancing the sustainability of energy systems. Connecting to SDG 7, energy efficiency directly supports the goal of affordable and clean energy by lowering energy costs and reducing reliance on polluting energy sources. This makes energy more accessible and less burdensome on the environment. The broader aim here is not just to save energy, but to ensure sustainable future. Improved efficiency reduces greenhouse gas emissions, supports economic savings, and extends the availability of energy sources. This alignment with SDG 7 facilitates progress across multiple sustainability goals. One of the main benefits of energy efficiency measures is reducing energy demand, which directly translates into decreased reliance on fossil fuels. This shift is essential for mitigating issues related to energy security and reducing our environmental footprint. Less fossil fuel consumption means fewer carbon emissions, aligning directly with global climate action initiatives. The environmental benefits here are clear. Fewer emissions of carbon dioxide and other pollutants, which improve the air quality and reduce the greenhouse gas emissions. On the other hand, economically, it means lower energy costs for consumers and businesses alike, making energy more affordable and accessible, which is a direct contribution to SDG 7. By enhancing efficiency, we not only make strides toward cleaner energy, but also support a sustainable economic growth. It's imperative that we continue to invest in energy efficiency and to promote other practices that enhance energy efficient measures and technologies. Here, it comes another significant issues. By reducing the overall energy demand through efficiency, renewable energy sources like solar and wind become more practical and economic. How's that? Renewable technologies often have a higher initial cost and are limited by the variability and intermittency in energy production. Efficient use of energy helps mitigate these limitations. By decreasing the total energy required, thus making renewable installations capable of meeting a larger portion of the demand, and this will be more effective. Moreover, energy efficiency not only reduces consumption, but also lowers the cost of energy. When this combined with renewable energy sources, which have lower operational costs once installed, the overall cost of energy can decrease significantly. This is crucial for making sustainable energy accessible and affordable, aligning directly with SDG 7. Now, another milestone in the relationship between energy efficiency and SDG 7, with a special focus on target 7.3, which dedicated to improving global energy efficiency. Target 7.3 under SDG 7 aims to double the global rate of improvement in energy efficiency by the year 2030. To achieve this target, the implementation of both policies and technologies is necessary. Policies may include regulations and incentives that promote energy conservation and the adoption of energy efficient technologies. Technologically, the focus is on developing and deploying innovations that optimize energy use, such as enhancing building insulation, which can significantly reduce heating and cooling, energy efficient appliances that consume less electricity, and smarter industrial processes that optimize energy use throughout manufacturing. From a scientific perspective, improving energy efficiency involves enhancing the thermodynamic efficiency of systems and reducing energy losses. Engineering solutions include the design and integration of advanced materials and control systems that help in achieving these efficiencies. All these measures will directly support Target 7.3 in SDG 7 by making energy more affordable and reducing the energy intensity of economic activities, lowering greenhouse gas emissions, and facilitating the shift towards cleaner energy sources. Okay. Now let's move into several significant barriers that can hinder widespread implementation of energy efficiency across various sectors. The first barrier is technology. Current technologies may not always achieve optimal energy efficiency. This could be due to the older designs that are inherently less efficient or due to the degradation of equipment performance over time. Upgrading or replacing these technologies with more efficient versions often requires significant investment and expense. In addition, advanced energy efficient technologies may not be readily available in all markets or may still be in developmental stages. The pace of technological innovation and its dissemination varies globally, often influenced by regional economic and policy factors. In some cases, the most cutting-edge solutions are not viable due to their high costs or the lack of technological support for installation and maintenance. Consider also integrating new technology into existing systems poses significant challenges, especially when the existing infrastructure is outdated. Many older systems and buildings are not designed to accommodate modern energy efficient technologies without substantial modifications. This can also involve complex retrofitting processes that require not only capital, but also significant disruptions to existing operations. Addressing these barriers requires engineered solutions that include the design and development of adaptable technologies that can be easily integrated into various infrastructure settings. Engineers also need to focus on developing transitional technologies that bridge the gap between old and new systems, ensuring compatibility and ease of integration. And here we need different system approach. Overcoming technological barriers to energy efficiency involves a systematic approach that includes research and development, policy support to facilitate the adoption of new technologies, and financial mechanisms that lower the barrier to entry for adopting advanced solutions. Additionally, of course, training here and capacity building are crucial to ensure that the workforce can effectively implement and maintain new technologies. According to a study by the National Institute of Standards and Technology, NISTT, approximately 70% of manufacturing facilities in the US are equipped with outdated energy systems. These statistics actually highlights a significant issue within the sector, where a majority of facilities are not utilizing modern energy efficient technologies. The use of outdated systems substantially limits the potential for energy savings in these facilities. Older systems are generally less efficient and consume more energy than necessary, which not only leads to higher operational costs, but also increases the environmental footprint of these operations. The barriers include the absence of advanced energy-saving technologies in these facilities. Reasons for this may include high retrofitting costs, a lack of technical expertise to upgrade existing systems, and potential disruptions to manufacturing processes that upgrades might cause. Overcoming these barriers requires targeted engineering solutions, such as developing retrofit kits that are cost-effective and minimally disruptive to install. Additionally, promoting the adoption of state-of-the-art technologies through incentives and support programs can accelerate the transition to more efficient systems. Regards the systematic approach here, it involves the assessment of energy consumption patterns, followed by the phased implementation of energy efficient technologies, can help also in managing the transition. This approach also includes the training for staff and maintenance teams to handle these technologies effectively. The second challenge is financial barrier. High upfront costs pose a significant barrier to adopting energy efficient technologies. These technologies, while beneficial in the long term, often require a substantial initial investment that can be beyond the reach of many individuals and businesses. This includes costs associated with purchasing new equipment, retrofitting existing systems, and any associated installation fees. From an economic perspective, the decision to invest in energy efficient technologies is influenced by the cost benefit analysis. While these technologies can lead to considerable energy savings and thus lower operating costs over time, the initial high costs can discourage stakeholders who are unable or unwilling to allocate significant upfront capital. Another financial barrier highlighted is the lengthy payback period associated with investment in energy efficiency. The time it takes for the savings from reduced energy consumption to cover the initial investment costs can be extensive, often several years. This lengthy return on investment can discourage potential investors who prioritize short-term financial gains over long-term savings. To overcome these financial barriers, engineered financial solutions such as innovative financing models and government incentives are crucial. This might include low interest loans, grants, tax incentives, and rebates that can help reduce the burden of upfront costs and shorten the payback period, making energy efficient technologies more accessible and appealing. Strategically investing in energy efficient not only aligns with sustainable goals, but also offers long-term economic benefit. Engineers and financial planners need to develop and promote cost-effective solutions and business models that make the economic case for energy efficiency more compelling, particularly in markets where such investments are still seen as prohibitive. According to a survey conducted by the American Council for Energy Efficient Economy concerning financial barriers to energy efficiency improvements, 56% of businesses identified high upfront costs as the primary barrier when considering investments in energy efficiency improvements. This significant percent underscores the widespread impact of financial constraints on the adoption of energy-saving measures across various sectors. The third barrier is behavioral barrier, or the general lack of awareness or understanding among consumers and organizations regarding the benefits of energy efficiency. This includes not knowing how energy efficiency can be beneficial, what measures can be taken, or the long-term cost savings and environmental impacts these measures may facilitate. Without a clear understanding, individuals and businesses are less likely to prioritize or invest in energy-efficient technologies. It's worth mentioning here that psychological barriers play a significant role in hindering the adoption of energy-efficient practices. Humans naturally exhibit inertia or resistance to change that can deter the shift from established habits to new, more energy-efficient behaviors. Organizational inertia can be even more pronounced due to the established procedures, cultures, or the perceived risks associated with changing long-standing operational practices. These behavioral barriers can significantly impede the effectiveness of policies and programs aimed at increasing energy efficiency. For instance, even with financial incentives or technological advancements available, the lack of engagement or behavioral resistance can limit adoption rates. Overcoming these barriers requires targeted strategies that addresses both awareness and psychological resistance. Educational and outreach programs can enhance understanding and awareness, while behavior can also change. Behavior can change interventions like social norms, campaigns, feedback on energy use, and incentives can be designed also to shift consumer and organizational behavior towards more energy efficient practices. From an engineering standpoint, designing energy efficient systems that are user friendly and require minimal change to existing behavior can also help. Integrating principles from behavioral science into the design and promotion of these technologies can enhance their acceptance and usage. According to a report from McKinsey, approximately 30% of homeowners in the United States are not aware of energy efficient programs that are available to help them reduce their energy costs. This lack of awareness is significant because it directly affects the uptake of programs designed to promote energy savings and cost reductions through more efficient energy use. Also, the lack of awareness among homeowners about energy efficiency program can lead to underutilization of available resources and incentives that are often provided by governmental bodies. Energy companies also has a significant role in promoting the awareness among homeowners about energy efficiency programs and measures. We have also to consider that this underutilization results in continued inefficiencies in energy consumption, higher energy bills, and which lead to increased carbon footprint, which finally counteract efforts towards sustainable energy use. From a scientific and engineering approaches, increasing energy efficiency in homes often involves upgrades to upgrades the heating and cooling systems, insulation improvement, and also the installation of energy efficient appliances. The effectiveness of these technical solutions can be significantly enhanced by widespread homeowner participation and compliance, which is currently hindered by the lack of program awareness. To overcome this barrier, targeted information campaigns, a community outreach program, and the collaboration between utilities, local environments, and the community organizations are necessary in order to increase the visibility of energy efficiency opportunities. Effective communication also has a play role uh, through utilizing the various media platforms and the educational workforce and incentives-based marketing to reach a broader audience. Uh, Also, we need to focus on the role of integrating principles from behavioral science can help in designing these programs to be more appealing and accessible. Now, let's discover the drivers of energy efficiency or what motivates the adoption of energy efficient practices. The first driver is policy initiatives that governments employ to promote energy efficiency. Governments often implement mandatory energy saving standards that require manufacturers and builders to meet specific energy efficiency criteria. These standards are crucial. These standards are crucial in designing to reduce the energy consumption of new appliances, vehicles, and buildings, ensuring that new products entering the market contribute to energy conservation efforts. Moreover, building and appliances codes are regularly or it's regulatory tools that require the minimum energy performance requirements for new and sometimes existing structure and equipment. These codes ensure that energy efficiency considerations are integrated into the design, construction, and retrofitting of buildings and manufacturing of appliances, leading to reduced energy use over the life cycle of products. Policies may also affect uh, energy efficiency uh, through setting efficiency goals for utilities, requiring them to achieve specific targets in energy saving through their operations and consumer interactions. This could also involve providing incentives for energy efficiency improvement among consumers, such as rebates for purchasing energy efficient appliances or financial assistance for home retrofit. Some policies mandate or encourage the conduct of energy audits for buildings and industrial processes, helping identify opportunities for energy savings and enhancing transparency in energy use. These audits are critical for understanding how energy is used and wasted, providing a clear roadmap for improving efficiency. Uh, from engineering approach, implementing these policies require sophisticated analysis and application of technological solutions. This includes the development of advanced materials, systems, and construction techniques that align with energy efficiency standards. Furthermore, ongoing scientific research supports the advancements uh, of standards and codes by providing data on the effectiveness of various technologies and practices. Solid example for the role of government policies in boosting energy efficiency. According to the IEA, government policies alongside specific energy efficiency measures have played a crucial role in reducing global energy consumption. These policies and measures ensure that energy resources are used more efficiently, leading to significant energy savings worldwide. A remarkable example provided here is the implementation of new building codes in the European Union, which have been estimated to reduce the energy use in buildings by up to 30%. These buildings codes set minimum energy efficiency standard for new and sometimes existing buildings, promoting the adoption of energy-saving technologies and practices such as better insulation, efficient heating and cooling systems, and optimized lighting solutions. The development and enforcement of such building codes involve detailed engineering applications, focus on understanding the most effective ways to reduce energy consumption through architecture design, material science, and system engineering. This involves integrating advanced technologies such as automated energy management system, high performance insulation materials, and energy efficient heating, ventilation, and air conditioning systems. So, to conclude, government policies play a critical role in driving technological innovations within the industries by setting uh, clear energy efficient standards. Government incentives companies also to develop technologies and solutions that meets these criteria, thus fostering a culture of innovation and sustainability across different energy sectors. The second driver is economic and financial incentives. Financial incentives such as subsidies, tax rebates, and grants are critical tools that can significantly reduce the financial barriers associated with these investments in energy efficiency. These incentives make it economically feasible for individuals and business to purchase and install energy efficient technologies by lowering the cost burdens. Dynamic pricing also involves adjusting the price of energy based on demand, thereby reflecting the true cost of energy consumption. This pricing strategy encourages consumers to reduce energy use during peak demand times, leading to overall energy savings and more balanced energy consumption patterns. From a scientific perspective, understanding the quantifiable benefits of energy efficiency can be enhanced by studying the impact of these financial and pricing mechanisms on energy consumption patterns. Engineering solutions, on the other hand, focus on developing and implementing technologies that can maximize the effectiveness of these incentives, such as smart meters and energy management systems that respond to dynamic energy that respond to dynamic pricing signal. The integration of financial incentives and dynamic pricing introduces both economic and behavioral dynamics into the energy market. Economically, these incentives help align the cost of energy with its environmental and social impacts, making sustainably a more integral part of financial decision making. Behavior, they leverage economic signals to shift consumer and businesses' behavior towards more sustainable practices. These incentives are often implemented through policy initiatives that aim to stimulate market changes towards greater energy efficiency. By reducing the cost of entry and rewarding energy savings behavior, policies can help create a market environment where energy efficient products and services can thrive. The third driver is ongoing technological innovations which drive improvements in energy efficiency. These continuous advancements allow for the improvement or development of more efficient processes and systems that use less energy to achieve the same or even better performance. One specific criteria or area of technological advancement is material science, particularly in developing materials with better insulation properties. Improved insulation materials help in reducing energy loss in buildings and industrial processes, significantly lowering energy demands for heating and cooling. Moreover, advancements in the efficiency of electrical devices facilitated by superior semiconductors and circuit designs are also crucial. These advancements help in reducing energy consumption in a wide array of consumer electronics, industrial machinery, and power systems, making them more efficient and less energy intensive. Additionally, breakthroughs in energy or renewable energy technologies are recognized as significant contributors to energy efficiency. Innovations in solar panels, wind turbines, and other renewable technologies not only provide cleaner sources of energy, but also enhance overall energy efficiency by converting natural resources into energy more effectively and at a lower environmental cost. Scientifically, these technological advancements involve extensive research and development in physics, chemistry, and engineering disciplines. Engineering applications, in turn, take these scientific insights and transform them into practical technologies that can be implemented in the market. The integration and optimization of these technologies into existing systems pose additional engineering challenges. It requires sophisticated design and control strategies to ensure that new technologies work effectively within the current infrastructure and contribute to overall energy efficiency. According to the Global Energy Assessment, technological advancements could enhance global energy efficiency by up to 10 to 30% over the next decade. This significant increase is contingent on the effective implementation of aggressive policies and necessary societal shifts towards sustainability. For example, improvements in battery technology can enhance energy storage efficiency, allowing for better integration of intermittent renewable sources like solar and wind. The fourth driver is awareness and education. By increasing awareness, individuals and organizations are more likely to make informed decisions that favor energy efficient solutions. Education helps to bridge the gap between knowledge and action. For example, campaigns that focus on the potential cost savings and environmental benefits of energy efficiency tend to be particularly effective. When these campaigns provide clear, actionable information, they empower consumers and businesses to implement changes that lead to real energy reduction. The final section of our lecture focuses on the implementation of energy efficiency. To start implementing energy efficiency, I prefer question methodology to stimulate deep and critical thinking. Questions such as those listed in this energy efficiency questionnaire, which will be examined now in details. Those questions play a crucial role in promoting energy efficiency within organizations. They serve as the diagnostic tool that helps pinpoint current energy usage and identify inefficiencies. By systematically addressing each question, organizations can critically assess their energy strategies, aligning them more closely with sustainability goals. These questions stimulate reflection and discussion among key stakeholders, leading to informed decisions that enhance energy management practices. Furthermore, they encourage continuous improvement by establishing benchmarks for performance and facilitating the adoption of advanced technologies and innovative practices. The first section of the questionnaire is about energy efficiency strategy, which outlines 10 critical questions designed to help an organization assess and refine its energy efficiency strategy. These questions cover various aspects of energy management, strategic alignment, and implementation in a systematic manner. Number one, alignment with organizational goals. This question probes how the energy efficiency strategy is integrated with the broader goals of the organization, ensuring that energy initiatives support overall business objectives. Two, energy reduction target. It asks for specific term, next year, mid-term, 5 years, and long-term, 10 years, energy efficiency reduction targets, which are crucial for planning and measuring progress. Number three, integration with design and renovation. The focus here is on how energy efficiency is considered in the design and renovation of facilities, which is vital for sustainable infrastructure development. Number four, prioritization of energy projects. This question addresses the processes in place to identify and prioritize energy efficiency projects, which helps in resources allocation and project management. Number five, evaluation of emerging technologies. It seeks information on how new technologies are assessed and integrated into the energy strategy, ensuring the organization remains at the forefront innovation in energy efficiency. Number six, matrices for measuring success. By asking what matrices are used, this question ensures there are defined parameters to evaluate the effectiveness of energy efficiency initiatives. Number seven, it's about staying informed on industry benchmarks. This question is about the methods used to stay updated with industry benchmarks, which is crucial for maintaining competitive and best practices. Number eight, funding and investment. It explores the approach to securing funding and making investments in energy efficiency, which is often a significant challenge for many organizations. Nine, about balancing costs and saving. This question addresses how the organization balances immediate costs against long-term savings, which is a key consideration for financial sustainability in energy projects. And the 10th question is about resilience to energy price challenges. It asks how the energy strategy is designed to be resilient against fluctuations in energy prices, which can impact cost effectiveness and budgeting. Overall, these questions are designed to ensure that an organization's energy efficiency strategy is comprehensive, up to date, and aligned with its broader goals, effectively managing risks and maximizing benefits. The second component of the strategy is about operational efficiency. The 10 questions aimed at evaluating and enhancing energy efficiency within operational processes. These questions are designed to guide an organization in assessing various aspects of its energy management strategies, focusing specifically on operational activities. Let's have a look on these questions. Number one, it's about optimizing energy consumption in manufacturing processes. This question probes how the organization is improving the efficiency of energy use within its manufacturing operations, which could involve adopting new technologies, optimizing production schedules, or retrofitting older equipment. Number two is about reducing energy usage during non-operational hours. It addresses measures taken to minimize energy consumption when operations are not active, such as during nights or weekends, which can include shutting down equipment or utilizing automated system to reduce power usage. Number three, measuring and managing energy performance. The focus here will be on the methods used to track and manage energy consumption of equipment, possibly through energy monitoring systems and regular performance evaluations. Number four, it's about training for energy efficient operation of machinery. The question asks about the training provided to employees to operate machinery in the most energy efficient manner, ensuring staff are knowledgeable about best practices in energy conservation. Number five, it's about conducting energy audits. It inquires about how and how often the organization conducts energy audits to identify areas for energy savings and to ensure energy consumption is as optimized as possible. Number six, it's about systems to detect and address energy waste in real time. The question checks for the presence of systems that can detect and rectify energy wastage immediately, such as energy management systems that provide real-time data and alerts. Number seven, it's about incentivizing energy efficiency goals. It looks into how the organization motivates operational teams to achieve and exceed energy efficiency targets, potentially through rewards, recognition programs, or performance-linked incentives. Number 8, it's about role of predictive maintenance in energy management. This question explores how predictive maintenance is utilized to enhance energy efficiency by preventing downtime and optimizing the performance of equipment. Number 9 is about ensuring compliance with energy efficiency regulations. It asks about measures in place to ensure that operations comply with local or international energy efficiency regulations, crucial for legal compliance and operational efficiency. Number 10 is about strategies for energy load management and peak shavings. The final question here delves into strategies employed to manage energy load and reduce peak demand, which can include load shifting, peak shaving techniques, and the use of on-site energy storage solutions. To summarize, these questions are crucial for organizations looking to enhance their operational efficiency, reduce costs, and minimize their environmental impact. Each question is designed to prompt detailed responses that can lead to actionable insights and improvement in how energy is managed and consumed. The third part of the strategy is concerned with the technology and innovation. The 10 questions here aim to evaluate and enhance the role of technology and innovation in an organization's energy efficiency strategy. These questions are designed to probe various aspects of how technology is integrated and leveraged to improve energy efficiency within the organization. Let's take a closer look at these questions. Number 1 is about innovative energy saving technology. It asks here about the new energy saving technologies that have been adopted over the past year, encouraging reflection on recent technological advancements integrated into operations. Number 2, it's about assessing the impact of emerging technologies. It inquires about how the organization assesses the impact of new and emerging energy technologies before their full-scale implementation, focusing on evaluation methods and decision-making processes. 3, it's about strategies for energy storage and integration, focuses on the organization's strategies for energy storage and how these are integrated with renewable energy sources, which is crucial for managing energy flow and optimizing renewable usage. Number 4 is about leveraging data analytics, questions the use of data analytics to optimize energy usage, exploring how information and big data are used to improve energy efficiency and reduce waste. Number 5 is about integration of electric vehicles, looks into the organization's approach to integrating electric vehicles into their fleet or facilities, which is a significant step towards reducing carbon emissions. Number 6 is about automation and control system. The question probes here into the usage of automation and control systems for energy management, highlighting the role of technology in monitoring and controlling energy use in real time. Number 7 is about pilot projects for energy efficiency. It asks about any pilot projects aimed at testing new energy efficiency solutions, emphasizing the organization's commitment to innovation and continuous improvement. Number 8, it's about culture of innovation in energy efficiency. Here, the question is about how the organization fosters a culture of innovation, specifically around energy efficiency within teams. And this question is crucial for sustaining long-term engagement and creativity in energy initiatives. Number 9 is about partnership for energy innovation. It explores how existing partnership or collaborations that focus on energy innovation, reflecting on how external relationship supports the organizational energy goals. Number 10 is about IT systems and infrastructure management. It inquires about the management of IT systems and infrastructure to ensure energy efficiency, highlighting the integration of IT solutions in energy management strategies. Overall, these questions serve as comprehensive framework for assessing the technologies and innovative aspects of an organization's energy efficiency efforts. They encourage a deep thinking into how technology can further enhance energy savings and sustainably within an operational context. The fourth part of the questionnaire is designed to evaluate policies and practices related to sustainability and compliance. These questions are essential uh, for assessing how deeply integrated sustainability is within the strategic and operational frameworks of the organization. Number one is about balancing profitability with responsibilities. This question here explores how the organization balances financial profitability with its environmental and social responsibilities. It's crucial for maintaining sustainable business practices. Number two, it's about strategy for sustainable growth. It prompts the organization's strategic planning for achieving sustainable growth and financial resilience, ensuring long-term viability amidst environmental and economic challenges. Number three, it's about funding sustainability initiatives. This question addresses how sustainability initiatives are financially supported and accounted within the organization, which is vital for transparency and effectiveness of these efforts. Number four is about promoting sustainable investment. It asks about the methods used to promote investment in sustainability, which can include both internal project funding and external investment strategies. Number five, it's about integrating sustainability in business model. The focus here is on how sustainability is integrated into organizational value proposition and pricing models, affecting how products and services are presented and priced in the market. Number six, it's about economic benefits from sustainability. This question seeks information on the observed economic benefits from implementing sustainability practices, such as cost saving, improved efficiencies, or enhanced brand value. Number seven, it's about engaging stakeholders on sustainability. It explores how the organization engages its investors and shareholders on sustainability issues, which is key to improving support and ensuring alignment on sustainability goals. Number eight, it's about ensuring fair trade and practice. The question checks what measures are in place to ensure fair trade and equitable economic practices, ensuring that the organization's operations do not exploit but rather contribute positively to the economy and society. Number nine is about assessing life cycle costs and benefits. This probes how the organization assesses the full life cycle costs and benefits of its products or services, from production to disposal, which is crucial for understanding the true environmental impact of its offerings. Number 10 is about transparency in energy efficiency reporting. This question inquires about how the organization's approach to transparency in energy efficiency and sustainability reporting, essential for credibility and compliance in environmental stewardship. Overall, these questions are aimed at ensuring sustainability is not only a part of the organizational policy discussions, but is actively practiced and integrated into all aspects of the business, from strategic planning to daily operations and external communication. Now, the following is a diagram that shows the 8 essential elements of successful energy efficiency strategy. Number 1, it's about comprehensive energy audits and benchmarking. This could be achieved through performing detailed energy audit to establish the baseline consumption and identify inefficiencies across various sectors. Also, it employs benchmarking against industry standards to measure potential energy savings and prioritize improvement opportunities. The second element is advanced energy management system. It's about implementation of energy management system across all sectors, guided by standards such as ISO 50001. These systems can facilitate operational and behavioral improvements, achieving up to 10% energy savings without significant initial investments. Number 3, it's about high efficiency technology upgrades. It's about upgrading to state-of-art technologies such as replacing outdated equipment with energy-efficient alternatives like LED lighting or high-efficiency motors, which can reduce energy usage by up to 75%. Number four, it's about energy-efficient building design and retrofitting through applying energy-efficient design principles in new constructions and retrofit existing structures to enhance energy performance. Also, through incorporating superior insulation and high-efficiency HVAC systems to potentially halve energy consumption in buildings. Number five, it's about regulatory frameworks and incentives through establish rigorous regulatory frameworks that mandate ambitious energy efficiency standards for appliances, vehicles, buildings, and industrial activities. Also, through leveraging incentives to encourage compliance and implementation of energy-saving measures. Number six is about education, training, and public awareness through developing extensive training programs for professionals involved in energy system design and maintenance, coupled with public awareness campaigns to foster a culture of energy conservation. Number seven is about continuous monitoring, reporting, and verification. And this through setting up through monitoring, reporting, and verification systems to track energy consumption and the effectiveness of implemented measures. Also, through utilizing advanced metering infrastructure and data analytics to validate energy savings and optimize performance. Number eight is about management review and continuous improvement. It asks about how you engage senior management in periodic reviews of energy data, audit results, and regulatory adherence to ensure progress towards energy efficiency goals, and also through the continuous refinement and enhancement strategies that based on performance data and evolving technology. This structured approach not only aims to reduce energy consumption, but also to support sustainable development by integrating technological innovation, policy support, and the community engagement into a cohesive strategy. Lastly, let's explore the key responsibilities of an energy efficiency manager. This role is crucial in steering organization towards more efficient and sustainable energy usage, effectively integrating strategic energy management into the broader goals of sustainability and operational efficiency. Number one is about energy audit and analysis. The energy efficiency manager is supposed to conduct thorough energy audits to assess the current usage and pinpoint the improvement opportunities. It's also about how to analyze energy bill and systems performance to establish a baseline for energy efficiency measures. Number two, it's about strategy development. And here it's about how energy efficiency manager craft and implement comprehensive energy conservation strategies through setting precise energy efficiency goals and plans to minimize energy usage and reduce the operational costs. Number three, I think it's very significant, it's about project management, supposed to manage energy-related projects from inception to completion, ensuring they adhere to planned budgets and timelines, and also to coordinate with various stakeholders to guarantee that projects meet technical specifications and efficiency standards. Number four, it's about monitoring and reporting through continuous monitor energy efficiency, energy consumption, and the effectiveness of implemented measures, and also to regularly report on energy usage, savings achieved, and the progress towards established goals, facilitating ongoing optimization. Number five, it's about training and education. The energy efficiency manager has to develop and to conduct energy efficiency training for staff to ensure their understanding and engagement in energy conservation practices. Also, to promote energy efficiency awareness throughout the organization. Number six, it's about technology evaluation and implementation. The energy efficiency manager has to assess and recommend cutting-edge technologies that enhance energy efficiency and stay updated with the latest development in energy efficiency solutions and to oversee their integration into existing systems. Number seven is about financial analysis and budgeting. Through performing detailed financial analysis to evaluate the viability of energy efficiency investment, Also, to manage energy budget, ensuring its optimal allocation or ensuring to ensure the optimal allocation of resources for maximum return on investment. Number 8 is about sustainability integration. The energy efficiency manager has to seamlessly integrate energy efficiency initiatives into the broader environmental strategies of the organization and to align energy saving measures with comprehensive sustainability goals such as reducing greenhouse gas emissions and enhancing corporate social responsibility. The energy efficiency manager rule is pivotal actually in steering organizational energy use towards greater efficiency and sustainability. This rule not only helps in cutting costs, but also significantly supports the organizational commitment to environmental stewardship and social responsibility. Finally, for additional insight on energy efficiency, sustainability, and decarbonization, please explore my LinkedIn profile where you will find over 150 posts covering a wide range of topics related to these critical issues. Additionally, my YouTube channel features numerous videos on energy, environment, and more. Thank you for watching, and I hope you have a fantastic day.